Hello everyone, welcome back to my channel. And it's been a long time. I couldn't find much free time to make these videos, so that's the reason I couldn't make any videos. But today, once again, so welcome back. And in today's session, I would be explaining about a simple concept on threads, launching a thread asynchronously. Suppose, say, one thread is running in the background and the other is running in the foreground. So, two threads are running parallelly, and we use the asynchronous and launch policy and the future object to get to call the get function and to retrieve the return value of the asynchronous thread. So that's what is today's concept. So let me start. Okay. So starting with the header files as usual, hash include IO stream. Okay. And then since I'm dealing with threads, so hash include thread header file, and then as I told you, I will be using the asynchronous threading concept. So whenever we deal with asynchronous, we have the future future class and its object to retrieve the return value. So hash include this header file is must. Okay. And then I will be inducing some delay uh, within the main thread and as well as within the background thread. So I will be using the chrono library. So because I will be inducing a sleep for function. So chrono library. Okay. Hashtag include chrono. Okay, fine. So now, um, so I will start with the main thread first. Main, as usual, it has the return value 0. Okay, so in the beginning of the main function, I want to print a statement on the console which says the ID, thread ID of the main function, right? So cout. Okay, this thread ID is okay. Main, this is a main function. So let me, okay. This thread ID is, I will be using this thread and then I will call the get ID member function. So, okay, fine. So now, before that, I have to use the namespace standard. Okay, done. Now it's fine. Okay, the first statement printed on the console is the thread ID of the main function, right? So then after this, I want to launch a thread which runs in the background. So this main function will be the main thread and it is running in the foreground with the so and so particular, it has its own thread ID, so it is running in the foreground. So there is another thread. I want to launch another thread which is executing a certain task, and that thread will be running in the background. So two threads, for one is in the foreground, the other one is in the background. So what do I do now? I will use the future object. Whenever I launch a thread asynchronously, I will use this future object. Okay, long. This is the data type of the return value. Okay, you can think that way. So this is the name of the object, and I want to launch asynchronously, right? So I will be using this function asynchronous, and then launch policy. Launch policy asynchronous. So I am launching this thread forcefully, yeah, because if I don't use this launch policy, what happens is the thread I can't the programmer can't give any assurance whether the thread running in the background is has a started execution, or whether it has completed, or what is happening in the background. The programmer won't have he can't give any assurance about whether the thread is running, or whether it has postponed its execution. So whenever we use this launch policy, the thread as soon as it gets launched, it will start execution at that very instant. So that's the reason we use this launch policy, because the thread has to start its execution, so without any postponement. Okay, so now I will be so what is the task task is the background thread executing? A simple one. Let's say it is finding a factorial of a number. Okay, factorial is the name of the function, callable object. Let's say with input parameter like 5, I am finding the factorial of 5. Okay, 5 factorial I am finding. Okay, so that's how it is. And then before that, I will define this function factorial. Return type will be long, and the name of the function is factorial. So as I said, the input parameter will be int n. Nth factorial we need to find, which I'm sending it as 5. So this is the callable object factorial. So once again, here I want to print the ID of that particular function. Okay, so what do? I copy this statement and place it here. So this is not a main thread, it is a background thread. Let me call it as a background. Okay, this thread ID is so and so. Okay, fine. So now after this, I want to find the factorial, right? I will use the for loop as usual. The concept of finding the factorial, start from 1. Okay, the loop starts from 1, and I less than n, less than or equal to n, right? And then I plus plus. So within this, we should have a so finding factorial internally, let's define one variable which has 1 initialized. And then so how do we find factorial? Successive multiplication, right? Also use this operator and multiply it with I. Okay, result is multiplied with I every time. Successive multiplication from 1 to n, so it gives you the nth factorial. Okay, fine. Now once you find this factorial, that would be the return that has to be returned to the calling function. So I am returning that. So that's it. So this is how it is. I have launched one thread, asynchronously, which is executing the task factorial, and it is running in the background. So once when it returns value, I need to retrieve that return value. How do I retrieve that return value in that in the calling function, in the main function? So we need we need to have a variable within us, say, let's say value. Okay, and this value will contain the return value of the factorial method. So how do we retrieve that return value? We have to use this future object and then call the get member function, get function. Okay, yeah, obviously member function it is. Okay, so now we have got the return value of the background thread. So if we do not call this get, then we cannot retrieve, or we cannot collect that returned value from the background thread. So this get is a must and should whenever you are launching a thread asynchronously. If you want that if you want to know whether the thread has completed its task, whether it has completed its execution or not, you should call this get function. It is must. And so when you call this get function, the main thread will be blocked, it will not terminate. Okay, the main function is blocked at this line, and once the get function is executed, once it retrieves the return value, then the main function uh, executes further, means it terminates, then the main function terminates. So suppose if you do not call this get, what happens? The main thread will definitely terminate, return 0, and then closing curly brace. So the main thread will terminate, and we do not have we have used the launch policy, and the thread is has started its execution, but what about the result? I mean, what about its return value? What about, how do we know that it has completed in the background? So for that purpose we use this get method. Okay, with the help of, we call it with the help of the future object. So that is done. So now, since this is the there is a foreground thread, main thread, and there is a background thread, okay, which is executing factorial. So these two threads run parallelly, and it is very quick. So we will try to induce some delay here using the sleep for functions. So for that, what do I do? Once I launch this thread, I will make the main thread to wait for certain period of time. So I will induce some delay. So I will copy this line. uh, okay, so for around, okay, 3, I want to this thread call the sleep for, okay, and then use the chrono library. Okay, chrono library, and I will use milliseconds. About how many milliseconds? I would say 200, and the for loop is for 3. So 200 into 3, 600 milliseconds will be very less span. The output what we get on the console should be eye catchy. We can find some delay on the output console screen, so I want to induce some much delay here. So let me say 1000 milliseconds into 3000 milliseconds. Totally there is a delay before we get the before we call the get function. So after a delay, there is we are calling this get function, right? So after that we have to print it on the console. So factorial returns, okay, factorial returns how much? Okay, okay, that's it. Okay, I have induced some delay here, and similarly I want uh, to induce within this, between every successive iteration of for loop there has to be a certain delay. So that's what I'm doing here. Instead of 1000, let me say 500. Okay, so that we can see some so that we so that the speedness of the multi-threading, the parallel execution is, you know, is after inducing this delay, we can find some eye-catchy delay on the console. Let's see after running this. Okay, the main thread ID is so and so, background, this thread ID is so and so, and then factorial returns. So what do I do now? I don't even find any delay on the console. It's directly printed at one single go. So what do I do? Okay, let me print it clearly, line by line. And let me check by inducing more delay if I could see some delay on the console so that it is eye-catchy. Okay, see now there you can find some delay before printing the return value, right? Okay, yeah, that's what I meant, because instead of that quick result, we can find some delay, so that it's more precise to understand, right? Okay, this is about how we how the two threads, one run parallelly, one in the foreground and one in the background, using the asynchronous asynchronous policy, launch policies, and the future object. And so this is a very simple program. Hope you guys understood. Thank you.